Um, I would say how we like with being an engineer. I'm not an engineer, but trying to be. With the goals of
You
trying to
are.
with the goals of trying to uh make things accessible for others and
Hmm.
to I guess when I think like in sustainability terms to make it inclusive or like to make it safe for the environment to
Hmm.
with the way we design things, I would think it in that way.
Yeah, definitely. Thanks, Daniel, for your input. Any other thoughts?
Yeah,
May
my name
I?
is Joseph. Hello.
Hey, Joseph.
Yes. I think social justice in engineering is it encompasses engineers or professionals adopting to the engineering practice as much as possible.
Hmm. Do you want to elaborate a little bit on that?
Um, I would say like engineering, take for instance civil engineering, there is engineering codes and practice
Hmm.
that a professional is supposed to adopt in executing their job, if it's in design or construction. You have to follow a policy or a guideline as much as
Hmm.
possible, adhere to those guidelines, and try not to do something different or that is unlawful.
Yes, yes. So, just to add to that, part of the issue in civil engineering, at least in the US, is we do follow codes and standards, but and sort of practices, but they haven't always been in the past applied equitably or written equitably. Um, and so sometimes by following codes and standards, which we're legally bound to do, we are furthering or continuing to do things in an inequitable manner. But thanks for sharing your ideas. I think there was somebody else who started to speak up, but I didn't catch their name.
It was me, Aksa.
Uh, hey, Aksa.
Yes, I would like to speak about like we all are, whether we are inventing a small chip or a large computer, it's for our humans, are for people.
Mm-hmm.
So being an engineer is our responsibility. So whatever we design in our engineering, in civil engineering, it should be based on the people demands and needs. It
Mm-hmm.
justify their needs, and we don't be biased about their between the classes of the people. It should be on the standards and codes, whether we are designing for a lower income society or for a elite class. So I think
Mm-hmm.
it's lie in that criteria.
Mm-hmm.
Thanks.
Yeah, absolutely. Thank you. Any other thoughts?
I feel that in justice, social justice in engineering is like putting all together about ethics, and not only about for engineering but for different areas, in order to do like stuff like properly working in order to terms and what is like functional for the world.
Mm-hmm. Yeah, absolutely. Any other thoughts? No? Okay. So there is a whole book um, written about engineering justice and how we can transform engineering practice into a more justice-focused practice. So how can engineers incorporate social justice into their practice? First and foremost, by listening, right? As a couple different participants mentioned, that we as engineers, especially as civil engineers, we're building stuff, we're building our technologies for people. People will be using what we develop, and so we need to listen to what they need in order to actually address their needs instead of doing what we think is best when we might not be as connected to that community and their problems as we might think. So number 2, identifying structural conditions. 3, increasing human rights. 4, increasing opportunities, increasing resources, reducing imposed risks and harms, and then enhancing human capabilities. So we can all, use this framework that's been developed by this group to help us think about how we can incorporate social justice into various aspects of our engineering profession. So these 7 steps are necessary for all engineers in any domain, at any level, and in any industry. This is a sort of universal issue, and I don't want to say this is a universal solution, but this framework can be applied universally. Absolutely. So there are a lot of examples. Most of these examples are focused on the US, but there are a lot of examples of where engineers interact with insecurity and injustice in various ways. So the first example we have here is building energy insecurity. So in the US, in particular, there's a big energy insecurity issue. So from this survey from 2015, there was various levels of insecurity reported by individuals in these 4 different categories. So reported any household insecurity issue, over 30% of households reported this. There was over 20% of households that had to either reduce or forego basic necessities in order just to pay their energy bill. Just under 15% of households received a disconnection notice, and then a little over 10% of households were forced to keep their home at an unhealthy or unsafe temperature just because they were unable to afford to pay their energy bills. And so it might be difficult to think about, oh, how can I as an engineer affect the price of energy? But we can we can always affect our communities, affect our profession by what we talk about and what we make important. And we can put pressure on our organizations to help address this issue and make it an issue instead of kind of just ignoring it because, oh, it's not a problem for me type of thing. So kind of the next thing we are talking about here is extreme weather events in the built environment. So especially as we talk about climate change and the temperature increasing around the world and having more drastic temperatures, both hot and cold, which we have experienced at least in Texas. In recent years, we've had some pretty harsh winters that our built environment is simply not built to handle. And so these conditions, these types of weather conditions actually make our social justice issues worse. We're building an infrastructure are concerned because we need to take some critical actions to improve our built infrastructure so that, the most disadvantaged of our members are not having long-term negative health effects or long-term financial effects as a result of this poor infrastructure. So this is a little bit of I don't know if I want to say a funny one, but one that we might not think about. So this is occupant comfort inequity. So Most historical studies of like office comfort was focused on men, and men have a different temperature comfort level than women. So generally men prefer the temperature colder than women. Um, and so the most office buildings are set to a cooler temperature, which then for the occupants, they are more optimal working conditions for the males in the building as opposed to the females in the building. And so it kind of, you can think about, maybe it's not a big deal, but if you are consistently a little bit more uncomfortable throughout the day, you might not perform at the same level. So there's also disability-related inequity in the built environment. Um, this is, we as civil engineers, we need to consider universal design for people with physical challenges. So there are, in at least in the US and probably in other countries as well, there are standards for designing for disabled individuals. However, or people living with disabilities, however, they're not always, like we talked about earlier with the listening to people, right? So we have in the U.S. something called the American with Disabilities Act, which dictates how we need to build our civil infrastructure to accommodate people living with disabilities. However, if you talk to people living with disabilities, in a lot of cases, they'll tell you, things are not actually designed to standard, or the standards are designing in such a way that it's not actually comfortable for them to maneuver and to get around. So if we can work with them to understand their discomfort in the built environment, we can shape our environment to be more accessible and equitable. So next we have sanitation and safe drinking water. Which is a huge issue worldwide. There's over 2.4 billion people on the planet that lack access to basic sanitation, despite the UN saying it's a basic human right. And even in the US, more than 2 million Americans live without basic access to safe drinking water and sanitation, which might be surprising. But there's a lot of places where people disadvantaged individuals live, particularly in rural areas that simply don't have access, or even in urban areas where their infrastructure is not adequate to provide clean water, which we get where you get sort of old lead pipes that then transport contaminated water that causes a lot of issues, in particular in some areas of the US. So water pricing, this is very, very similar to the energy and security issue listed earlier, wherein water prices are increasing, and it's pricing some poor Americans out of the ability to afford water. So there was a study that found that water rates have increased by 54% across the U.S. since 2010, and that was just over 7 years. So for people who do not have additional income that they can kind of freely spend on increased water prices, this is making it very difficult for some families to pay their water bill. So this is also related to climate change that we talked about a little bit earlier. As climate change is becoming more and more of an issue, not only is it affecting people's kind of comfort with their built environment, but it's causing more and more floods and droughts, right? And so as we're getting more rainfall concentrated in heavier events, we're seeing our stormwater infrastructure being overwhelmed more often. So floods are the second deadliest of all weather-related hazards in the US, and they account for approximately 98 deaths per year, mostly due to drowning. And then on the other end of the spectrum, we have drought, which poses a huge public health risk and safety, and especially if you're talking about drought and water access, it negatively affects people's water security. Um, Even in some places like the US, where we think that it wouldn't be such an issue, there are areas where we rely on surface water for providing our water resources. and drought negatively affects the access to surface water in particular. And then it also potentially causes a number of additional environmental factors that can negatively affect people, such as wildfires, dust storms, and extreme heat events and flash flooding. So over just the last 2 decades, floods and droughts have affected over 3 billion people with kind of unthinkable costs in human suffering and economic loss. In Texas alone, they've had almost more than a $1 billion flood event almost every year in the past 10 years. It's pretty insurmountable if we continue having to deal with these issues at this rate. So we've talked a lot about how how justice is integrated with our engineering, but sometimes it's a little bit hard to translate that concept to research. So research definitely also has a lot of inequality issues. So over time, the structural stratification of U.S. universities has been increasing. So this figure here that you can see, if you the straight line that goes from corner to corner, that would be perfect equality. But as you can see in the US, these dashed lines over here kind of on the right, we're getting farther and farther away basically from this straight line, which indicates that we are, inequality within across our institutions is increasing. And I'm sure this is the case in many countries around the world, not just the US. But part of the issue that creates this inequality is that 80 to 90% of financial resources in the US are concentrated among the top 10 to 20% of universities. So there's just a very large number of universities that do not have the financial resources. But then you have, on the other hand, these well-established elite universities that are getting, a lot of the research dollars and a lot of the endowments from wealthy individuals, who want their name on a building or whatnot, are giving, large amounts of money to start programs and whatnot. And you might think, well, why does that matter? Like, how's that influence research? But if you have more funding, you will always pretty much always have the ability to conduct more research, because if your university has more funding, you have more money to buy equipment, more money to train personnel, more money to have the support that you need to actually manage and supply and apply for grants for research funding. And so this is a huge issue where if you don't have, it's kind of like the saying, I'm not sure if you've heard of this one before, but like, you need to have money to make money, right? So you need to have some research equipment and some skills developed to apply for research funding to then do more research, right? So it's really hard to get research funding if you do not have any research equipment or training or anything available yet at that point. So this sort of inequality also affects the ability to conduct research. Sorry. So there is also a legacy of inequality in research funding across different types of universities. So in this figure, you can see that there is inequality in research funding between both public and private universities, but that over time, whereas for a while it was actually going down, over time we're starting to see this inequality start to go back up. So this inequality is kind of heading in the wrong direction, where more and more money from federal grants and contracts is starting to be focused on these more elite universities. So research inequality isn't only confined to different types of universities, but also, at least in the US, different races. So this figure shows racial inequality in NSF proposal funding rates. So you can see this is from only 2019. So This is not overall, but this trend is common, right? It's seen in almost every year. So what we see here is that proposals submitted by white researchers have been funded at a much higher rate than what would be expected based on their, fraction in the total population, basically, whereas we have proposals submitted by Asian researchers are funded at a lower rate, and we have sort of similar trends with Hispanic or Latino researchers, Black or African American researchers, Asian, or sorry, American Indians or Alaska Natives, and then Pacific Islanders or non-Hispanics. So there are issues not only with the types of universities, but with race as well. And I don't have a figure for this, but gender also comes into play, and I'm sure there's a number of other inequalities we could discuss if we dug deep. So we've talked a lot about these different types of inequalities, but what can we do about it? We can adopt practices in our research that help combat these inequalities. So that's kind of what the whole goal of this bootcamp is to teach you how to make your research data and processes as easily accessible as possible so that others can use them to help answer their own research questions. And this kind of concept is what has led to the FAIR data principles, which we'll talk a lot about this after the break, but FAIR data principle stands for findable, accessible, interoperable, and reusable. So we want to make our research products, our research data and our research products as fair as possible to help people who don't maybe have as easy access to that data and to that research process to be able to conduct research as well, because they have, researchers all over the world will have a valuable insights to add to the to the to the research findings, to the science domains, and that's one of the things that we as researchers can help guarantee. So without further ado, I think that is it for me. Does anybody have any comments or questions about kind of this inequality in research and how we can address it through our own practices? Okay, so if not, if you have, if you will complete a survey, I was supposed to do this at the top of the lecture, I forgot. So that's my bad. But Dr. Forbes has put a link to a pre-survey in the chat. So if you could take a few minutes to fill that out, I would greatly appreciate it. The link is in the chat here. And then we will take a break, one of our scheduled breaks. And so we will meet back up at 10:45. So you have a little over 15 minutes to start discussing FAIR data principles in more detail. But in the meantime, if you could complete the pre-survey, that would be fantastic. And I'll pretty much stay on if anybody has any questions. And thank you. Yes, Grace?
I was just curious. I didn't necessarily super understand the chart on structural stratification in universities. I was wondering if you could explain that a little bit more.
Yes. So this, I'm looking at the chart. Let's see if I can pull it up over here.
I'm seeing it on the screen. Yeah.
Okay, perfect. So this line right here, the solid line that goes from corner to corner, is perfect equality. And this perfect equality would be between the cumulative proportion of income that the university receives. And then the bottom is the cumulative proportion of institutions. So if the amount of money that your university receives is equal to like how many your proportion of institutions, basically, that would be perfect equality, right? So if I had 10 institutions in the whole country, just for the sake of easy numbers, and they all received $100 million or something, that would be perfect equality, right? Because all of my institutions are receiving the same amount of money, right? But here we have let's just look at the like US public line. Okay, that's the easiest one. That's the bottom one right here. Can you see my cursor?
Yeah. Yes, ma'am.
Yeah. So in this case, we have about 80% of universities in the US. If we're looking at here, US public universities are receiving about 30% of the total income received by all public universities across the US. But then we have here, if we go see this really steep line, that's kind of what's indicating that a large number of a lot of funds is being provided to a very small number of universities, right? So if we follow, just for the sake of argument, let's say about 50%. So 50% of the income in the US at US public universities is going to only about, I want to say like 92, about 8% of universities, right? If we follow this line down, it's about to 0.92 perhaps. And so that's how you read this, where the steeper the line is on this side is showing that more of the wealth is concentrated in a smaller number of universities, whereas here the really gentle curve is showing you that a very small amount of money is spread over a lot of universities. Does that make sense?
Yeah, thank you so much. It's so
Yeah, you're welcome.
interesting that the private universities are somewhat better than the public. That's interesting.
Yes. Yeah. It's probably because there's a lot more private or public institutions, than there are private universities. I would imagine is part of it. So there's universities of every size and rank that are public, and they're the smaller public universities are less likely to have a large or a wealthy alumni group, right? Whereas if you have there are historically some really prestigious small private universities that have received endowments that are 5, 10, 20 times the size of what a not state standard public university is. So I think that's probably what causes it. Yeah. Thanks for asking.
Yeah, no, thank you.
Yeah.
Dr. Eisman,
Yes, Joelle?
can you please go forward 2 slides? I want,
This one?
yes, perfect.
Mhm.
Yeah, I just wanted to get a better chance to look at it.
Yeah.
Did you say this presentation is going to be uploaded to GeoHub?
I think this one already is uploaded to my GeoHub, so yes. It should be available under the Engineering Justice lecture tab. And I've
Perfect,
also,
thank you.
yeah, you're welcome, included the citation here, so you can go look it up if you want. There's a ton more figures and tons of different ways they look at this over different time frames in this paper listed here. And there's a couple other papers as well that do a pretty good job talking about it, if it's something that interests you.
It does, thank you.
Yeah, you're welcome.